Well, good morning, students. Here we are again, having to meet in this way virtually. And so today I'd like to actually move us a little bit away from where we've been interacting for the past couple of weeks on circuits. You'll remember that we have spent some significant time looking at the nature of circuitry, the direction of electron flow. I showed you last week the difference between two different kinds, or this was 2 weeks ago, two different kinds of circuits. A circuit where you have components that show up in series, so there's a series circuit, there's only one path for the electron to go, or a parallel circuit, so that you have multiple branches or paths for the electron to go. And then it was last week we studied on that fundamental principle the nature of resistance as it changes between those two different kinds of circuits. So we've been studying circuitry for a while now. You remember some of the components from the wires and a switch through the parts that would sit on a circuit, so resistors, lamps, motors. We for today are going to look in depth and focus in on one specific component of a circuit, and that is the battery. Now you have got batteries around you all day long. In fact, you may even be watching this on a device that requires a battery, whether that's a laptop or maybe a cell phone. But I bet you probably haven't given much thought to how does a battery actually work. To study a battery, even like the one you would use to start a car, right? A car battery is going to involve chemistry. So electrochemistry is really going to give us a lot of the physics of what's going on under the surface, and that's going to go beyond the scope of the video in the study that I want to introduce us to for this week. But I'm going to link an additional video. I think I'm going to probably put at least 2 supplementary videos for you to take a look at if you want to study it a little bit more. What's really happening is that you have 2 different elements that each have a different electron affinity, and so that desire either to lose an electron or to gain an electron is going to produce an unbalance between the two so that you have an ionic flow or the transfer of electrons, something that's called reduction oxidation that's going on inside of the chemistry. So there's a lot more that could be said on that, and it probably goes beyond the scope that we're going to talk through today. But what I'd like to do is I'd like to address something we saw a few weeks back. I think it was in a video I showed. Luigi Galvani had a frog. Do you remember the video that showed the picture of the frog leg? That when they breached the gap there with some static electricity that had gathered up upon the scientist's clothes and touched on the nerve of the frog, that it caused the muscle of the frog leg to actually contract. And they thought that this was something called animal electricity, or that there was electricity that was contained inside of animals. Well, that property of how electricity can chemically be stored and then transferred is what I want us to look at today. And I want us to do an experiment. What we're going to do is we are going to create our very own battery. We're going to make what's called a wafer battery. Sometimes it's referred to as a galvanic battery. You might find for different teachers or wherever, whoever is happening to address this may have a different name for it, but we're going to do it with things that you can find right at home. So I'm going to have you go and find 2 different coins. Wherever you keep maybe a jar or a handful of spare change in the house, you can ask your mom or dad to help you find 2 different sets of coins. We're going to try to get 8 pennies and 8 nickels. And these 2 coins have chemical properties that make them up from 2 different elements that find themselves on 2 different sides of the periodic table. So they have a difference, a potential difference between them for their electron affinity, which when stacked like wafers with something in between them that allows for that ionic electron transfer, called an electrolyte, when they're stacked like wafers like that, they will induce what's called a potential difference. And we learned a few weeks back that that's called a voltage. And I think you'll actually be surprised at how many volts one of these small homemade batteries can produce, just with things that you have laying around the house. There's a few other things that we're going to need to do this experiment. You're going to need some vinegar. So hopefully your mom or dad have some vinegar that is somewhere there in the house. There's probably, if you don't have vinegar, you could use a few other things as a substitute. Lemon juice, if you have a lemon, or anything else that's slightly alkaline. That's something that produces a pH off from normal. Something lower or higher than 7. If it was higher, we would use acids, but we're going to stay away from acids for this experiment. We just want to get something that's alkaline. Maybe a potato would work for that, but vinegar is going to work for us for today. And then some table salt. If all you have is table salt, then I pretty much guess you could find some table salt. We may still be able to make it work. So just things laying around the house, and for that wafer that's going to be in the middle for the electrolyte transfer, we're going to use a paper towel. You could also use some thin cardboard, like something that would be very almost paper thin cardboard, not the kind of shipping cardboard is probably too thick unless you could tear it in half, or like a coffee filter. Coffee filter will work fine. So if you can gather up those ingredients, we'll try to make a wafer battery together. And again, think you'll be surprised with how much voltage can actually be created with it. The part of the main things that I want to introduce you to is the concept of electron flow, the fact that it's something that can be produced just with household objects and items, and then we'll talk about specifically just the name of the two ends of a battery, one that produces a positive charge called the cathode, and the other half of it that produces the negative charge called the anode. And that for today hopefully is going to give you a greater appreciation for these things that are in our world all the time, that we likely have taken for granted without even recognizing the amazing science that has gone into using and utilizing the refinement of electricity for technology. So with that, let's take a look at how we can make a wafer battery. Okay, so in order to do this experiment, you're going to need to find some spare change. This is the jar that my wife keeps all our spare change in. And so what you should do is find some, and what you want to look for is taking out 8 pennies and then 8 nickels. Now I've already got 8 of them set aside over here. One of the things that you can do once you have your pennies and your nickels is you can maybe just wash them under some clean water just to get them cleaned up a little bit. I have some warm water right here in this dish, so if you just give them a little rinse that way, in case there's any oils on them at all, and they can be a little dirty, they don't have to be perfectly clean, just to get any oils that are on them rinsed off with some soap and water, rub them around for a minute, and then we'll dry them off, and they should be ready to stack after that. You're also going to need some paper towel. We're going to use this for first of all for drying them off here, but then also it's going to serve as the wafer that's going to go in between each of the layers, and that will serve as our electrolyte with our solution that we're going to make. 2 of the other things that you're going to need are some table salt. So grab some table salt. That's just a big jar, but you can use some that comes right out of the shaker if you have some on your table or in your pantry. That will work. And then some vinegar. I have red wine vinegar, so this is red vinegar. Apple cider vinegar will work, or white vinegar works the best too, but see if your mom or dad has some of that you can use as well for this experiment. Okay, so first thing we're going to do, and I'll show you how we have 8 of these here. So I'm going to set my nickels out, 4x4, and pennies 4x4 here. One of the things that we want to do is make sure that what we use as our electrolyte inside each of the layers needs to be smaller it needs to be smaller than the diameter. Let's see where I have my screen here. It needs to be smaller than the diameter of the coin itself, because what you don't want to have happen is you want it to jump the gap, because we'll lose some voltage every time that happens. So you want to make sure that they're smaller, and one way that you can do that, if you wanted to be extra precise, is by folding some paper like this, and then you could fold it over. This is just a paper towel, and you could simply trace around your coin like this here, and that way you'll get an exact circle. And then with this circle, if you wanted to cut that out, it's a little tricky, but what you'll find is you'll get nice, perfectly round wafers to go in between each one that make sure they won't overlap. So there we go. And now when I break these apart, you'll see that we have just a whole bunch here to use. Perfect. Now I might need a little more than that. We'll see, because you'll need them to fit into every layer, but that's all right. Okay, so let's get our solution for our electrolyte ready. I'm sure there's ways that you can do this that are a little more measured, but I am just going to pour what is roughly a, looks like 1/8 of a cup, maybe 1/4 cup. It only needs to be enough that you are able to dip the stack in. So that is not very much at all, not too much to worry about there. And then for the salt should be about a teaspoon's worth. So that's about a teaspoon of salt. And we'll just give that a little bit of a mix up, and I think we're good to go now on this. So we have our solution ready. Now we need to make our stack. I think it's easiest if you start with a nickel. So begin with a nickel, then take one of your wafers here to put in between. And what you want to do is just start alternating one and then the other. So now let's put a wafer in here. And then I just put a copper penny down. So now I'm going to put another nickel on top of that. And another wafer. And then a penny. And you just want to keep alternating. Just like this. Always make sure that you put one of the paper towel spacers in between each one of the layers. Okay, we've reached the end of our stack. So now, as you can see, we have alternating layers that have the nickel with some plating on it, metallic plating, alternating with copper plated pennies, one after another, alternating all the way up for a total of 16. And this is going to create a battery. So there will be a large potential difference. Well, it's pretty small, but larger because we're not doing just one or two, but we have 8 here stacked one after another between these two ends. Now, the copper here is going to have the positive charge that's going to want to attract a negatively charged electron from the nickel side down here. And so when we have a battery, we have a term for this. The term for what we'll call the top here that is positive is called the cathode. So top of your battery, that's the positive charge, is called cathode. And the negatively charged end is what we call an anode. The negative side is where the electrons are actually going to travel from negative to the positive. But when we think of the direction of the current, we always think of the current traveling from the positive to the negative, even though the electrons are going to be making their way up to the positive. All right. Now, this by itself will not work yet. It won't work because it has no way for those electrons to breach the gap here until we add a solution. And in a battery, many times that's an alkaline solution, which is why we call them alkaline batteries, or even a lead alkaline battery, using lead as one of the metallic surfaces. But here we're going to be using what we have created with the vinegar and the salt. And this is called a brine solution. So what you need to do is, and I'm going to get, let me see here. I'll use this
piece of the paper towel right here so I can rest it on it. All you need to do is just dip one end of it in just like that, and then flip it over, roll it around a little bit so it soaks into the layers in between each. And there we go. Now this is ready to serve as a battery. So I'm going to rest it down right here so that we can see if there is any current that's flowing. So I have a multimeter here. We have got a place to test batteries specifically. So a 1.5 volt battery are those kind of AA or AAAs. This is from one of my son's drone, his drone controller that he actually lost the drone to, so it's no good anymore. But if I take and put the negative on the negative end, gotta hold it on there, and put the positive on, you'll see this is, yeah, so this is a battery that's weakened a little bit. It should read 1500 here, or would be 1.5 volts, and this is about 1.3. So this battery is dying a little bit here. But if we put the negative here at the base of the stack, and I attach it to the top, you will see, look at that. There is a voltage right now reading, look at that, 600. So that would be 0.6, almost 0.7 volts. So half, almost roughly half of this battery that you can buy at the store, we're finding voltage coming through our stack of coins that we made with just household items, salt and vinegar. If I put it over here to milliamps, millivolts, there we go. And one of the things that I found interesting is that as I press on it, if I press a little bit harder and close the gap between those two sides of the metal, the voltage changes. And that's because some of that fluid, the electrolyte fluid that's in between, is getting squeezed out, and it's making a tighter connection between them sometimes. One way that you can see this is working if you don't have a multimeter like this is you can find, maybe you have laying around in an old junk drawer, an old little LED light. I've got one here, and then this one. This is an old style. If you just were to squeeze on it, you can see a little lights up there. And we can test to see if there's enough current here to actually light this LED. All right, and you will see all there is, put this together, very simple little LED light. Little battery, again, positive end, we would call the cathode. See the big plus right there? And then on the negative side, this is called the anode. And as that makes contact here with our, oh, well, now it seems like it's not wanting to work. Oh, gotta have the direction. So this diode, remember, is one directional. So positive here, negative. Let's see if I can bend these leads without breaking them. It's setting, its rating is too high, and this little stack here is too low. So I would need to have quite a bit larger stack to see it light up. And I'm trying to cover to see if there's anything showing in the dark. No, nothing on this one. Maybe this one here we can get to work for us. Let me see if I can open this one up. Alright, the only trouble with this is you'll notice our little circuit board here is also showing that there's a switch that we have to press down to get it to turn on. And these wires are not bare yet. So, well, that's what happens when you have not properly purchased the correct voltage rated LEDs so that the experiment can work. But you will see if I turned our voltmeter on one more time that as there's no current flowing when nothing's attached, all I have to do, put one on the bottom, one on the top, and sure enough, look at that. Almost 1 volt. So we were at 0.8 right now, 0.9 volts. If I turn it down here, you'll see 0.7. There's 0.9. Wow, really close. So very close, but this here, a simple little experiment so you can see what the inner workings of what's going on inside a battery. Just these different metals with their electron affinity, and it has to have what is that tiny little electrolyte wafer in between each one so that those ions can pass through, and sure enough, right at home, you can make a homemade battery. I wonder what would happen if we added stacks upon stacks upon stacks. I wonder how much voltage we could make if we took this entire jar and tried to make a battery. Wouldn't that be fun? Might have to try that another day. Okay.
Well, I hope you enjoyed taking a look at how we make a battery. And you know what? There's a lot of more technology than I can even cover in this video, or that I could produce in home, with how some modern batteries are made. In fact, right here I have a lithium-ion battery. And a lithium battery is using a little bit of a different technology for ions than just the wafer style and structure that we have. In fact, there's some new technology that's coming out right now for solid state batteries that seem to have some amazing properties. If you've ever gotten frustrated with a cell phone battery dying, well, solid state batteries might be the holy grail for long-term energy use and repeat charges too. We can't add charge back very efficiently to nickel cadmium or anything close to the copper batteries that are alkaline, like the ones that we made today. Lithium-ion batteries are unique in that they can be discharged and recharged again over and over, but even these have a limit to what they're capable of doing. But solid-state batteries just blow everything out of the water. So who knows what we'll have in the next 5 to 10 years. But I wanted to thank you for participating today. I want to wish you guys all the best and encourage you to stay safe and have fun. Bye.